Welcome to qnawire.
So now we're going to work on problem 87 from chapter 8. In this problem, we're told about how phosphates are used to soften water, which usually, hard water usually contains calcium and magnesium. And so what happens is the phosphates will form insoluble precipitates with these ions, calcium and magnesium, and remove them. So if we have a solution of a certain concentration of calcium chloride and magnesium nitrate, how much sodium phosphate do we need to add to 1.5 liters to eliminate these ions? So first we can write out the reaction between the two species that we're talking about. So we have 3 calcium chloride reacting with 2 sodium phosphates. Here, these is already pre-balanced to form calcium 3 phosphate and 6 sodium chlorides. And we have a similar reaction for magnesium nitrate. So you could go ahead and write these down if you're not sure how to balance. You can write the whole reaction and then balance at the end. So this is how we form the insoluble phosphates. And this is the ratio in which the phosphate and magnesium and calcium will combine. So we're given volume, 1.5 liters, and we're given concentration for each of the reactants for calcium and for magnesium. So we can then calculate the moles of each of them. So we have 1.5 liters, and then we multiply by the concentration of calcium chloride. And this gives us a value of 0.075 moles of calcium chloride. We can do the same thing for magnesium nitrate, 1.5 liters times the concentration, which is 0.085. And we get Mg2. And so this gives us 0.1275 moles of magnesium nitrate. So we can combine these two because it doesn't really matter what their identity is. They both will react with sodium phosphate exactly the same way. So when we combine them, we get 0.2025 moles of calcium and magnesium. So here we multiply by the molar ratio. So for every 2 moles of sodium phosphate, we have 3 moles of calcium and magnesium. Again, the ratio is the same, so it doesn't matter that we combine them. So that will give us moles of sodium phosphate, and then we can multiply by the molar mass of sodium phosphate, which is 163.97 grams of sodium phosphate over 1 mole. And then our final answer here is 22 grams of sodium phosphate. That is how much is needed to remove all of these hard water ions.